Alright, we should be streaming, so let me know if you guys can hear me. Welcome to Unit 1 World Quant Office Hours. Alright, and y'all should be able to hear me hopefully, so do let me know. Do let me confirm that for me, so we can get rolling for today. Alright, I believe I am connected. I see Paolo is here. I see someone else. Entertainment's Everest, apparently. Hello, let me know if you can hear me. I see Andre is here. Shakiba is here. Hello, everyone. Welcome to Unit 1 Office Hours, new week. I see Jennifer is here. Alright, so thank you for letting me know you can hear me. Thank you for the confirmation. Desmond is here. Alright, welcome, guys. Welcome to World Quant Office Hours. Vivek is here. Let me know what you think, certain things you want me to talk about, so I can put on the agenda. But the very top of the agenda, I see the DW mini project. So we'll pick up our ventures and making progress towards the DW mini project. But do let me know additional topics I can throw up on the agenda. I see Tom is here. Emmanuel is here. Welcome to World Quant Office Hours. All right. Let me know additional topics to throw up on the board. But where we left off was the DW mini project, talking about Q4. We're talking about Q4 of the DW mini project. So of course we'll pick it up right there. And as we go through these mini projects, we're also doing little small lectures about pandas, pointing some stuff about pandas, reinforcing concept of pandas. Pandas is the Python package you'll be using for data analysis. In fact, so sort of the roadmap that we are taking is, well, we're right here in the DW mini project, the DW mini project. We've come a long way. The next thing that I plan to do is, once we wrap up the DW mini project, is let's go ahead and take the code we've written in that mini project and let's package it together. Let's package it into a script that we can run and repeat the analysis on different files of different years, repeating our analysis. So that's what we're going to go ahead and do. And of course, in that journey, in that adventure, we'll be learning additional skills and tools. And this will be used as a primer as we work on some sort of a project together, perhaps a web application that we can deploy. So that's the roadmap. All right, so I see a couple of people have joined us. RDX is here. Hello. I see Anna is here. Kinjal, hello. Daniel is here. I see someone has a question. So I'm going to take a look at the chat here. Okay. So it looks like there was a problem and the computer crashed, and when I got back to work, the PW was totally lost. The way you can get another copy of it is if you go to, let me go ahead and recovery. This here explains how you can go ahead and regenerate copies of the mini projects. So take a look at this. I'm going to put this here in the chat, and I got to sneeze. Hold on. Sorry about that. All right, so take a look at that. Follow the set of instructions. Basically, you open up a terminal. We show you right there. You run a couple commands, and basically what's going to happen is you're going to regenerate the given directory. So you'd regenerate the data wrangling directory, and then in the new directory you'd go in there, and there will be the mini project. So take a look at that. Try it out. If you have any follow-ups, do let me know. All that I ask, one thing that I do ask, is if you're to run this here. In fact, I can quickly do it. I'll quickly do it. Let's open up terminal, cd into data course, and then run the update module script and data wrangling. And now I have a new data wrangling directory in which the mini project should be in there. And I suggest that you copy it over and put it in your old directory. Okay, so I tried that too, but it says no such module. Perhaps it's a misspelling. Let's see. Or do you make sure you spell the script correctly? If it says no, if I misspell it, update module, I say data wrangling, right? No such file directory. Make sure you spell it properly. Update underscore modules. Do keep me posted if you get that resolved. I do want to make sure you get that resolved. All right, so I'm going to transition into the DW Mini project, but if there's anything else that comes up, do let me know. All right, so how about this? For Jennifer, if you let me know your username, I can go ahead and after the office hours, I can go in there and set it up for you. How about that? So do let me know your username, and I can take care of that. So just put your username here in the chat, the account you use to sign in, and I did ls and copy pasted. Okay, yeah, just put your username, and I can go and yeah, work on it after the lecture. Okay, so let's go ahead and transition to the DW Mini project. All right, we're working on the Scripps anomaly. So we talked about the problems with the chemical data set, and we've dropped those duplicates, and notice there are some differences in the number of rows, so we fixed that problem. And now we want to join this data set here. Take a look at the head with our prescriptions. So let's look at our prescriptions. So we say scripts.head. And the BNF code should correspond to the chem sub, I believe. That's where we're going to bring in the name of the drug. And once we do that, so if we were to sketch out our strategy, let's go and sketch out our strategy, is we're going to first join chem and Scripps together. We're going to join them, merge them in. And our next strategy is then we are going to flag prescriptions that are opioids based upon their value of name. So in other words, in this name field, if one of these opioids appear in this list we have there, if one of these strings appears anywhere in the name, we're going to call that the opioid. And then once we flag that prescriptions that are opioids, then we are ready to do our statistical analysis. So let's focus on this part here. Joining in the data sets and then flagging the prescriptions that are opioids. Okay, and since we want to bring in two data frames together, we got to do a merge. So I'll do that right there. I'm going to say Scripps merge on chem, and then we have to figure out what fields, what columns we're going to perform the merge on. So we've got to link BNF code to chem sub. So we'll say left on, left on, since the left one is the first one, the prescription, Scripps, left on BNF code, right on think it's called just chem sub. Chem sub. In fact, let me go ahead and backtrack. I think I'm doing something. Let's actually, sorry about this. Let's actually flag. Let's go, let me think. Actually, it doesn't quite matter. Sorry about that. We can do it this way. All right, so this is going to bring them together. And we're going to do a left merge. Go ahead and do a left merge here. So in other words, we're going to bring in all the records on the left and only bring those on the right they had a match. So how equals a left merge. And we'll assign this, we'll call this scripts. Call this scripts and chem. We'll run that, and let's go and examine sort of the top 5 rows, just to make sure things went as expected. And we have, all right, it looks like that was successful. We have chem sub and BNF code. They seem to match. We brought in the name. All right, so the next thing we got to do is you got to figure out a way we can go through all the records and flag those that are opioids. Go through the name column and figure out whether it contains an opioid or not. So before we do this in Pandas, sometimes it's nice if we ask ourselves, how do we do this on an individual level? How do we do this on one particular record? In other words, I open up a new cell here and I say scripts and chem, and I say ilock of 0, and let me just use lock. I say lock of 0. And then I say give me name. So I'm going to give, this is going to return this particular value. And given this string, we want to check, right? We want to check. Let's come up with a strategy. Let's come up with a strategy where we check whether the string in column name appears in, to check whether any of the strings in opioids list appears in the string in the column name. I see Kinjal has a question, so yeah, let me address that question just in a bit. And Andre, yes, that is our ultimate goal. Once we have, what we want to do is we want to add a new column to our data frame. That's called, is opioid, with the value of 1 or 0, true or false, whether that prescription is an opioid. That's our goal right now. Now we got to figure out, how do we generate that column? How do we go about checking whether this string here appears, if one of the opioids appears in our name? And the best way to do that, or one way that's helpful to do that, is just go ahead and do it for a single case. So we'll come up with a strategy of how to check whether any of the strings in the opioids list appears in this string here. And we know how to do membership checks in Python. So in other words, I can say opioids, and I can say, let's say opioids, I can say 0, and I can say in, let's say, morphine, something. I can do that. I can say opioids in some string, and this will tell me whether this string appears anywhere in this substring appears anywhere in this string. Right, I say opioids 1, and that's false. I say opioids 2, I get false, because, well, the other ones are different values. So methadone doesn't appear, but if I say methadone, or I say something something, methadone, that does appear. This string does appear in this other string. So we know how to do membership checks. All right, so now what we can do is we can say something like, there's actually several ways to go about this. So I could say, well, how about we do some sort of comprehension? What if I say for opioid in opioids, and then I say opioid in the name of the string. Sorry, in the name field. So notice this returns to me nothing an array of Boolean values. An array of Boolean values. So here I am iterating through the opioids list, checking if it appears in the name. And since I want to see if any of those are true, I can use the any function in Python. Use the any function in Python. And this here will tell me whether any of the values of the iterable are equal to true. And so if I know how to do this on a single entry of a column, then I can replicate this for all the entries of the column. So in other words, what I can do is I can say scripts in chem, and I can say name, and I use the apply method. And the apply method allows me to take a function and apply it to every single value of a column. So given this, let's go ahead and encapsulate this into a function. And since I'm going to only use this function perhaps just one time, just for this instance, it makes sense to use an anonymous function. So I say lambda x, and I'll say lambda name just to make it readable. I'll make my code more readable. And I can say for opioids, for opioid in opioids, and I say name, I say opioid in name, and I call any on that list. I get a syntax error, so it's probably something, maybe forgot an extra parenthesis or something like that. I believe that's the case. And a float is not an iterable. So apparently opioids, let's see, for name, for opioid in opioids, opioid in name. It says type error argument type float is not an iterable. So apparently I try to iterate through a float. And let's just see the type of opioids. Well, that's a list. In name, let's see what should be the type of name. So if I do apply on name, that should be a string. So there's probably, I see what can be the problem. Let's see. If I say scripts in chem, name, let's see if there's any null values. Is null, and some, I got some null values. There is some null values out there. Quite a few. Quite a few, so maybe I have some sort of mistake that I gotta correct. Alright, let's see the shape of this data frame. Alright, so about close to 1 million records. Something is going wrong. Okay, so maybe what I should do is, let me go ahead and do drop NEN. Might have to improve on this strategy, but if they drop NEN, that drops any of those missing values, and that gets the... Alright, that seems to get something closer. Well, I get a result. I get some sort of result here. Although now I'm a bit concerned because, well, I seem to have a lot of missing values. So let's see if we can fix this issue. Okay. Yeah, I see someone is late here. My kernel has died. Oh well. Keep in mind that we do keep track of playlists of all the Office Hours videos, so you can always go back and watch them. So keep an eye out for that. All right. Yeah, so looks like what's the problem here, as Gita is saying, is that we need to do a left join. I thought I did a left join. I did do a left join. I did do a left join on the scripts. And, yeah, I can see it. Let's see how we can best fix this. All right, so since my kernel died, unfortunately, let me do kernel, restart and clear output. Do cell, run all above. Okay, I'm going to run this here. Okay. So there's quite a few null values which are going to happen because the null values arise if I go back here, I am doing a left merge. In other words, I am bringing all the records on scripts, but only bringing in the ones from Chem that had a match. So there's gonna be some prescriptions that don't have a match, so they fill in with an NEN. So I could use perhaps an inner join. So in an inner join, I only bring in the records that had a match, and this goes back to what someone Kinjal brought up about. We got the same results with a inner join. Because at some point, we will have to drop the records that didn't have a match. So we had to drop in the records that didn't have a match, and that is equivalent of doing an inner join. So to recap, is if we do a left merge or left join, we bring in all the records in scripts, but if they don't have a match in Chem, then we fill in those values with NENs. But with an inner merge, we require for them to have a match. So if I go ahead and do an inner merge, then I can perform this here without calling drop NEN. All right, so that seems to have worked out. And I take a look at this code, and it's a lot that's going on in this piece of code. So maybe there is a different strategy I can take. So another strategy I can take is I can use the isIn method. So if I say name and I say isIn, and if I give it an iterable, then what this is going to do, it's going to check whether the value in this column is in this iterable. If I look at this here and I compute sum, I get 0 true values. There are no true values here. So this here was a bit verbose, so let's go ahead and see if an alternative, and the alternative is to use the isIn method. So every time you find yourself wanting to see whether this value of a column is in some iterable, you could use the isIn method. However, this gets nothing but false values. I can compute this sum. This is a Boolean column. False will be 0, trues will be 1s, but there are no true values. And the reason why is because the strings in name are in capital letters, have capital K's. And our opioids are all lowercase, so this is going to be a problem. So what we should do is we should lowercase the strings in names. And I can do so easily by accessing the string attribute and calling lower. And now this is going to lowercase all the records of name. And now I'm ready to say is in. All right, and now I'm ready to do that. And let's compute the sum. I still get 0. Ah, bad day for me. Let's see. Because I actually want to do the reverse. I actually don't want to use, the is in approach, because the is in is asking whether this value of this column is in any of the iterables. But I want to ask the reverse question. I want to see whether the values in the iterable, any of those are in, I think it's just be opioids. Sorry, it should just be opioids because that's already a list. Let's see. There, I think, okay, there you go. I've been restored. I think that should work out. In fact, now, since this returns a Boolean value, what I could do is I can say scripts in chem and create a new column called is opioid. And now with the new column, make sure spelling, I misspell that, make sure I spell that correctly. Okay, scripts in chem. And I call head. And yeah, and I don't know, for some reason I passed a list of opioids, had a list that had a list. So it said, oh, of course there are no values, because I had a nested list for some reason. Opioids is already a list. All right. So now we have a new column where we have flagged where the prescriptions are opioids or not. If I wanted to see how many opioids I flagged, well, since that column is a Boolean, I can index into it and compute sum. So true values have a value of 1, false have a value of 0, and we got about 9,000 opioid prescriptions. All right, thank you for bearing with me there. Okay, all right, and let's see. Okay, so now we flagged all the prescriptions that are opioids. And I think we're ready to move forward just in a bit. But let's go ahead and check out some of those prescriptions that we have flagged as opioids. So I can say scripts in chem is opioids. And since that's a Boolean value, I can use that to index my prescriptions. So here are all the records that have been flagged as opioids. So I see things like fentanyl, and so forth. All these things, yeah, those appear to be opioids. All right, so I think this has worked out. Let me take a look at the chat. A couple of things I should address. All right, I see Jennifer's username, so I'll make a note of that. I have administrative access to everyone's pods. So once I have your username, I can go ahead and get in there and see what is going on. So thank you, Jennifer. All right, I see someone is having access trouble getting to their pod. All right, looks like that has been resolved. Keep in mind that we have a playlist of all the past office hours. If you go back to Control Panel, video links at the way bottom. And I try to do that the same day. So if you miss part of this office hours, no problem. It'll be part of the playlist. All right, and let's see. Yeah, forgot the lowercase, and someone's saying, I like it when Don makes mistakes. He looks more like human, and I feel less stupid. Yeah, I like, when I teach, I like to make mistakes. Well, let me preface this. I like to make a healthy number of mistakes. I am human. I make mistakes. I struggle learning stuff, right? I have to put some effort in learning stuff. It doesn't come to me naturally. I have to put some work and effort into it. And when I make mistakes, I try to walk you through my process in fixing that mistake. So, of course, you don't want me to make too many mistakes, because then who wants to see an hour of me just making mistakes? A healthy number of mistakes, right? That's what we want. So I appreciate that you do like when I make mistakes, that you appreciate when I make mistakes. All right, I see Malcolm is joining us. Welcome, Malcolm. Okay, so now one of the things that I've realized is maybe we're not doing this very efficiently. So what I've done here is our process that we merged in the two data sets, and then we flagged whether a prescription is an opioid. But whether a prescription was an opioid or not, that was determined from the chem data frame. So let's go and recap what we did. Let's visualize this. So we have two data sets, and one is bigger than the other. In fact, we'll go ahead and verify that ourselves. We can take chem shape, and that's about 3,000 records, and we can do scripts shape. And that's close to, if I do this right, about 1 million records. About 1 million records in scripts, and 1 million in about, now I forgot, I think about 3,000 in chem. And notice that we flag a drug as an opioid not on a value of scripts, but on the value of chem. And what we've done is we've taken this larger data frame, we merged these two guys together, and then we went through and flagged whether a prescription is an opioid or not. We added that new column. Maybe it would be better if we create the new column in the chem data frame first. This is called chem. This is our scripts. Maybe it's better that we create the new column here, because this only involves going through 3,000 records, and then we'll do the merge. So maybe this was a better strategy. While we may arrive at the same answer, this might be the more efficient strategy, that we create the is opioid column in chem and then merge with prescription. Because this here has about, 3,000 records, and this here has close to 1 million records. So with that said, let's see if we can go ahead and do that let's go and perhaps revise our strategy later. And someone is asking the question about hows, different merges. And I kind of glossed this over, but it's time to talk about the different merges that we could have performed. So let's go back to where we created the merge. All right, so here there are 4 basic merges that can be possible. And they differ on what are the records we exclude and what are the records we include. So let's say we have 2 data frames, just like we have here. We have scripts and we have the chem. If we do an inner merge, let's do an inner merge, see what happens when we do an inner merge. An inner merge. What we do is we go through the records, the rows of one of the data frames, and we look at the column we're doing the merging on. In this case, we did it on BNF code and chem sub on the other one. We only bring in records in which there is an exact match. In other words, we take the first column, we look at its BNF code, we look at the other data frame, we say, hey, where is that BNF code? Do you have that record with that BNF code? Oh, you do? Merge them together. Go to the next record. Look up the BNF code. Look up the chem sub. That's the one we're merging on. Oh, we have a match. Bring those two records together. We go on to the next one. BNF code. Okay, where are you in the other data frame? Oh, I don't find you. I don't have your record. Then I'm going to exclude you from the output. Exclude you from the merge since you didn't have a match. That's an inner merge. Then there is a left merge. And a left merge, we go for the first row, we take the BNF code, we find its partner, we merge it in. Take the next row, look at the other data frame, we find the partner, we match. We go on to one of them, we take the BNF code, oh, we don't find your match. We don't find your match on the other data frame. However, since we're doing a left merge, we are still going to include that record. It's a left merge signifying that we're going to include all the records on the left data frame. This is our left data frame. So, since we're bringing in the record, then the question is, well, there are certain values. What are the values should we put for the columns that we couldn't find? Since we couldn't find a match on the right data frame, we have to use some value for that record. Since we're going to include all the values on the left, what about the ones on the right? Well, since we don't have those, we didn't have a match, we use NaN. So in other words, if a record on the left doesn't have a corresponding record on the chem, the values that the column values that should have been brought in, or they're going to be brought in, since they don't have a match, we use NaN. So that's a left merge. So when you do left merges, you're going to have cases with NaNs, missing values, which is what we saw. Which is what we saw when we did a left merge here. Remember, there were certain names that were missing that had NaNs, and that caused a problem in my workflow. Well, it's because they were missing. They were missing. I did a left merge, so I forced bringing all the records in prescriptions, and I had to fill in those missing values with NaNs. Inner merge, you're not going to have any newly created NaNs from the merging operation. So here the better approach would be an inner merge. There is a right merge, which is just like the left, but it's on the right's perspective. In other words, we include all the records on the right, but only bring in those on the left that had a match. And finally, there's an outer merge that says bring in all the records of both data frames. We'll fill in missing values when they happen. In fact, if you type in SQL joins and look at certain images, you can take a look at some of these images. So in SQL, they're called joins, pandas are called merges. But you can take a look at any of these images here, and they can kind of, nice little diagram of the different merges. So I'll put that right there. Now Google's complaining because it's too big. The link is too big. So let's see, copy image, or let's see, copy image address. So that's a quick run through all the different merges. All right, so we talked about the strategy is to add the new column before we do the merge. Now let's clean up our code. Let's go and clean up our code. It's a bit messy, right? That's what happens when we work on these things. We experiment, we have messy code. But let's go ahead and clean it up. So what I have here is chem. What I'm going to do is I'm going to say chem is opioid is equal to chem, and I say name string lower, and I say is in opioids. And then I can say scripts and chem is scripts merge. And notice I'm bringing in all these other records, all these other columns I don't really need. Let's only bring in the ones we care about. So let's merge with chem, but only bring in the records, the columns I care about. So the chem sub, the opioid column, the is opioid column is opioid. I'm probably misspelling that. Let's just double check. Is, copy that, and paste it right there. Okay. And I say left on BNF code, right on chem sub how equals left. Inner, right? I talked about how we need to use inner, so let's choose inner right there. And it should be a list of lists. There you go. Okay. And now I take a look at my column, sorry, my data frame, and there we go. And now we are good to go. Yeah, so inner is like the intersection. Yes, exactly. And that's why I find I think the diagrams say a lot. I think they explain pretty well. All right, so now that we've determined, now we have flagged, and I'm going to go and put this, yeah. Now that I flagged my prescriptions as opioids, then I am ready to do my analysis. So what I got to do next is I want to figure out the average number of opioid prescriptions a given practice makes. Because I want to figure out certain practices that might be over-prescribing these opioid prescriptions. Maybe they're over-prescribing it. Maybe we want to investigate to see maybe some malpractice is going on there. We want to figure out the average number of opioids for each practice. So once again, we find ourselves asking, I want to do X for every Y. So that means I need to group my data frame by practice. So that's what I'll do right there. I say scripts and chem. I say group by practices. And then since I want to calculate the average number of opioid prescriptions they give, what fraction of their prescriptions are opioids, essentially I want to calculate the average of this column. And notice it's Boolean values, no problem, because a false has a value of 0 and true has a value of 1. So I can say is opioid, and then calculate the mean. I'm going to call this opioids per practice. I get a key error, because I guess it's called practice. And all right, so let's examine my results. Opioids per practice, call head. And now I have the average number of opioids each practice prescribes. So let me know if there's any questions right now of what I've done so far. Okay. So now we figure out the average opioids per practice. We want to figure out the relative opioids per practice. And the reason why we're doing this is because we are trying to calculate the z-score. The z-score here. And the z-score tells us how many standard deviations away some value is from the mean. So you can view that these opioid rates, prescription rates, come from some sort of distribution, some sort of normal distribution. And there might be a practice that has a value there, maybe another one there, a value there, a value there, and a value there. So this here is, this is the prescription rate, and this is a frequency. The x-axis, the y-axis, some sort of frequency. So notice that most of them are concentrated around a central value, but there are some practices that prescribe at a very low frequency, and there's a certain number of practices that prescribe at a very high frequency. And what we want to do is we want to take this normal distribution and normalize it, cast it as a z-score. Figure out your prescription rate as how many standard deviations away you are. And this is important because if I were to tell you that this practice has an opioid prescription rate of, let's say, 5%. Well, is 5% a lot? Is it not so much? It's hard to tell. It's hard to tell without comparing it with some relative value. Right? If I say the opioid prescription rate is 1%, well, is that might be small, but how does it compare with everything else? So in order to do this, we have to calculate the z-score. And the z-score in general, is x, some value x, subtract from the mean, and we divide by the standard deviation of our statistic. In this case of x. Divide by the standard deviation of the process. So notice how it tells us how many standard deviations away from the mean we are. Think of it as normalized. So now, if we take our values and we calculate the z-score, then for our practice, if we have a z-score of, 3, that means it's 3 standard deviations away from the mean. And if it comes from a normal distribution, we know where it falls in this graph here. And then we can look at how many, what fraction of practices had a higher z-score. And this is important because if the practice has a z-score of 3, and I run the math, and only, let's say, 0.3% of the practices have a higher z-score, then that's a very high z-score. That's a very high z-score. If the z-score is, let's say, 1, and I do the math, and it ends up coming out that about, about 33 practices have a higher z-score, well, that's not so high, right? It, of course, is greater than the average, but there are 33% of the practices that have a higher prescription rate for opioids. So that's perhaps not that rare. So that's our motivation here. We're going to calculate the z-score of the prescription rates, and then you can imagine we can sort those from the highest to the smallest and have a cutoff and say, you know what, z-scores of 5 or greater, there's something fishy going on with those practices. Perhaps we should investigate them. Maybe it's benign. Maybe those practices deal with lots of cases where it makes sense they're prescribing a large number of opioids. The whole point here is let's go ahead and find these anomalous practices so we can further investigate and make sure everything is going fine. So calculate the z-score. And since we're working with z-scores since we're calculating the z-score of a mean value, we divide by the standard error. So it's a standard deviation of x over square root of n. N is the number of observations. So our goal here is to calculate for each practice this z-score. And we already got one way closer there. We already calculated the average prescription rate of opioids for each of the practices. We already calculated x bar. And then we proceed to calculate so opioids per practice, but now we got to calculate the numerator, the relative difference. You can go back here, and that'd be opioids per practice minus the global average. So we see this equation. This is the average across all the practices. Well, since we want to calculate the average prescription rate across all the practices, well, that tells me that I don't have to group by. I'm not doing a group by operation. Right? So I can just simply say scripts and chem is opioid and calculate the mean. So this here calculates the prescription rate across all the practices. And we do the deviation, so now we have the numerator. Now we've calculated the numerator for our z-score. Okay. Any questions people have regarding the z-score and our motivation? Okay, so now we got to calculate the denominator, the standard error. So the standard deviation of the opioid prescription rate across all the practices divided by the square root of the number of prescriptions for each of the practices. So in order to calculate this denominator, I need two pieces of information. I need the standard deviation of the opioid prescription across all the practices. So what that means is I need to calculate. I can go ahead and say scripts and chem. I can say is opioid and calculate the standard deviation. So there's a method called STD which will calculate the standard deviation. So that should calculate the standard deviation of that field, and now I got to divide by the square root of the number of prescriptions for each of the practices. Now my question to you is, how do we calculate the number of prescriptions of each of the practices? Any suggestions on how I should calculate that? How I should go about in Pandas calculating the number of prescriptions for each of the practices? So let me know. I'm going to write out some notes here. Yeah, so we can do a group by. Exactly, we can do group by. I say scripts and chem, and I can say group by, and I can say practice, and then I can say count. I can say practice and is opioid and say count. Let's spelling counts, right? So this here calculates the number of practices, exactly, group by and count. Number of opioids for each practice. All right, so we're good to go, right? We can go ahead and do that. However, let me show you an alternative. Let me show you an alternative which tends to lead to a little bit cleaner code, right? And while there's a nice built-in method in pandas of a series that will tell us how many times each value appears in that series. So in other words, if I take scripts and chem and I say practice, and I want to know how many times each practice appears in this series, each practice value appears, I can use the values count method. All right, glad Jennifer, that worked out for you. All right, so values count is another way to go about getting these values. So values count the number of times each unique value of a column appears. So it's not quite like n unique, because n unique tells us the number of unique values. And this here is telling us the number of times each unique value appears in the series. So they're somewhat related, but n unique is just give me the number of unique values. And by default, values count sorts the output. Notice it's sorted. That's why we see different results here. But no problem. We can always call sort values. And I can say ascending equals false. And I can compare the two. And they seem to be the correct answer, right? They seem to be correct. At least the first 5 and the bottom 5. So now, what we could do is notice that the column is these practice values. So now let me go ahead and take this here. So I'm going to divide by, let's do this in multiple lines. Divide by, I'll do the values count. Just keep in mind that this is perfectly a valid approach. However, I like to use the values count. It's a little more, quote, faster. Faster in the sense of writing things out. And now I can calculate the standard errors per practice. Take a look at that, standard errors per practice. Take a look at the head. And now I have a column of the standard errors for each practice. So now I have a series where the columns are the practice code. And now I am one step closer to calculating the z-score. I got the numerator and got the denominator. And then tomorrow, we'll pick it up where we're going to calculate the z-score and further work on this problem. This one's a bit of a long one, but I think there's a lot of opportunities to expand and teach about little mini lectures on pandas. So I didn't make it as too far as I thought today, but I think we are on track to wrap up this mini project definitely by the end of the week. So with that said, guys, we'll pick this up tomorrow. Thank you for coming to office hours, and have a good rest of your day, and see you tomorrow.